Hello everyone, this is question 2C from the practice exam of 2023, Computation 2. This question asks us about debugging. So we are giving a faulty code which has many bugs, and now we have to find them and fix it. It's always good to start off by reading the question as to what it says, as it might have some like special tricks or something which is not usual to an FSM. For example, reading carefully this one, it is written that when reset is asserted, that's when you should take it into normal, so change the states. But when the reset is low, that is when you should reset it. So reset every register to their initial state. That is one thing which, for example, this FSM has it as a specialty, and if you read it here, you'll find it. And yeah, so it's always good. It's always good to firstly read the question before continuing with the question, as it might have something which is not specifically shown in the diagram. Even though here you can see that okay, if when reset is 1, you should go here. In any case, yeah, it also writes, I believe, around here. Yes, so yeah, when synchronous reset is low. Okay, let's start from top. And okay, we see there is input clock, there is input reset, there is output coin in, there is output soda, output coin out. Now you can see here, for example, output coin in, that does not really make much sense. And if you check it here, it says, and the coin input signal is 2 bits wide. So the first problem is that this one should be an input. Okay. Now we continue down. These parameters, they're chosen randomly. They don't matter since we are not asked to display the state. It does not matter at what order we'll choose the parameters. Now we continue down to the registers. Let's check if we have enough bits to be able to like represent decimal 6. So yeah, with this is so the state registers, they have 3 bits, and that would be enough to represent decimal values up to 6. So check, that's a check. And now we continue down and up to the positive edge clock. And now we see, okay, the first thing is that we want to make sure that only when reset is 1, do the state update. Otherwise, they should reset. And this is not a usual FSM thing, and it only writes here in the text. So you should be very careful for that in the actual exam. So we change the reset to 1. So now when the reset is 1, it actually should act normally. And when the reset is 0, it should reset that. One thing which you can already also notice is that we are doing here blocking assignment, and that is not really allowed in a positive edge clock. And now we should do here non-blocking assignment. So only when the clock edge rises, that's when the synchronous registers, they will be assigned to the asynchronous ones. Okay, this part is done. Now we can save this one and we can continue down. Okay. Here what we can see is that, okay, if you want to not infer any latches, we want to have, for example, we want to kind of always drive the signal, and we should drive them, for example, here, like coin out next is equal to coin out R. So you should drive them with their synchronous counterpart. That would mean that you would do state next is equal to state R, and then soda next is equal to soda R. Okay. Oh, one thing that I can already kind of start to notice is that here we have state soda next, sorry, but then here it's only with nxt. And if I only double click on this one, I can see that Here at the positive edge clock, it's soda NXT. Down here, it's all soda NXT. So thus it means that I should change. I think it makes more sense to change here and also here. Yeah, so then we have the same variable name, otherwise it would be a problem. Okay, now after you check this up, you want to go and now let's check all the transitions. Let's make sure everything inside the transition is correct. Okay, let's start with the first one. Okay, we start with put coin. At put coin, okay, soda next, coin out next, they should be 0, as we can see from this finite state machine. Then we have that if coin in is 2b00, so if it is 2b00, it should loop back at put coin. It's fine. Now we go at 01. Okay, at 01, so we can see which transition. Okay, so it should go to input 1. That is correct. So state next should go to input 1. And now we say, okay, now we check 1 0, the output 1 0. That goes to soda out, but we can see here it goes to input 5. So this is not entirely correct, and we can also see that 2b, so the coin in 1 1, that goes to input 5. So this we should swap this and this. So I'll just swap them out. Take this and then place it here. Okay, let's make it neat. Okay, so I swapped their places. Okay, this seems good. Okay, now we can continue down to the next state, which is input 1. Now let's go soda next. Okay, and coin out next. We can see here they're 0 0, they're fine. Now we go to the coin in 2b00. That's gonna kind of loop back into it. That's also fine. And then we go 0 1. Let's check. 0 1 should go to soda out, but ours goes to input 6, so that's not okay. Okay, now we should go and check coin in 1 0. This goes to input 3, that's correct. And then 1 1, that goes to input 6. So that's not good. I'll just write input 6. Okay, so now we have the first two states. We made sure that they're correct. So that's good. Now let's go input 5. Input 5 is here. Its next state should be return 1, coin out should be 1 0, and soda should be 0. Correct. Let's check input 6. Okay, 0 1, coin out next, soda next is 0, input 6. Oh, so we can see here already a mistake. The state next of input 6 is input 6 itself. So we don't want it to loop with itself, but we want it to jump to input 5. So we can check this one. And now when you go to input 3, that's 0, 0, 1. Next state should be soda out, return 1. That's 0, 0, 1. 0, 0, 1, and then it's soda out the next state, and then here put coin 0, 0, 1, and the default should say like that. Now let me okay, so I run it and I see that I don't pass all test cases, so there has to be some problem. Now what we can do is we can use the logic analyzer to kind of try to find out where the problem is. Okay, so now at the logic analyzer, okay, one note which I want to also make here, this tool is very useful to debug where the problem is, because you're always given a reference, so how your outputs should look like, and the DUT, which stands for device under test, which means how your finite state machine outputs are actually. So then you can like immediately spot where the problem is. Okay. Now getting back. Okay, so we can now see. Let's at the DUT. Let me just plot my coin out. Okay, you can just like drag and drop like this. Coin out, and then also my coin out, and I also want to see my soda. And okay, so I have my coin out and soda. Now I go to the reference. I put the coin out of the reference of how it should look like, and also this soda. So first two things I can already notice is that my coin out starts with 1 0, and that's not how it should be. And also I can see if I put also the clock, I can see that I'm kind of lagging. So yeah, these are mine, and this is the reference. I can see that I'm lagging 1 clock cycle behind. Okay, so we have spotted two problems. First, that we start with 1 0, and that we are lagging 1 clock cycle behind. Now, if I go back and go down here, the problem is that all of these ones, so state next, coin out, they want to kind of have basically the next, what the next is going to be. If you check this one again, say coin out reference, coin out DUT, and I open this one and say now, okay, my coin out, yeah, and now I say my coin out next, and I can see, and what I can see is that my coin out next actually matches the coin out of reference, right? And also if I go, yeah, also so that should match, right? So if I now replace this, so my soda with soda next, so NXT, coin out NXT, and now let me, okay, it puts, there's some problem. Oh yeah, I forgot the T. Okay, let me save and run. Okay, now I can see that I pass all the test cases. And yeah, so this is for the debugging. Always make sure to read the question carefully. Be very careful, so the bugs might be anywhere from input to output, size of bits, even local like parameters, but in this case we're not outputting the state display, so that doesn't really matter. But for example, you can have the same number here, so you should just be careful. Also, an advice is if you can somehow figure out so what the actual bug is in the debugging, it's wise that while during the exam, what you can do is also rewrite the whole FSM how you would do it. So clean the buggy code and rewrite it yourself. The on course accepts also that one. So an advice would be that during the exam you spend up to 10 minutes per se on the debugging, and if you cannot figure out where the problem is, then I would advise that you kind of try to rewrite it, and you might get it done. Well, thanks for watching.